Okay, so we're on to mole calculations, video tutorial C, and today we're going to try to talk in detail about the mole and what it means. Let's remind ourselves from last time what the term relative formula mass and relative atomic mass means. Here's an application of working with RFMs. Common exam question. So it could be, you could be asked how much aluminium can be obtained or extracted or got out of 80 kilograms of the ore aluminium oxide. So what do we do here? Now we look at the formula, aluminium oxide, Al2O3. So we know that from this formula there's that amount, 2 lots of aluminium in all of the aluminium oxide. So we could look at it as a fraction or a ratio or even a percentage from the relative formula mass. So what you do is you find the start off with, let's find the relative formula mass of aluminium oxide. Now if we go and look at the periodic table, aluminium is in group 3 and aluminium has a relative atomic mass of 27. So we would go simply 2 times the 27 for the aluminium, okay, and then the relative formula mass, remainder of that formula is the oxygen, and oxygen we've seen before, but oxygen has a relative atomic mass of 16. So we go 3 times 16, and if we add all of that together it works out to be 94. The relative formula mass of aluminium oxide adds up to 94. Now we're interested in the aluminium part of it. So how much aluminium is in that 94? So we simply look at the 2 times the 27. That is actually how much aluminium is present. 2 times, is it 27 or 23? 27, yeah. So 2 lots of 23, get my 27, sorry, even, I'll get my calculator out. Work it all out. Here we are. Sorry about that, should have worked it out previously, shouldn't I? But me being a bit of a wally. 2 times 27 equals, I make that 54. Okay, so 54 lots in this is the out of 94 is the aluminium. So if you want to know, I would say as a fraction, it's going to be 54 over 94. 54 over 94 of aluminium oxide is actually aluminium. And I'll go back to the question, and the question was, how much aluminium could I expect to get out of 80 kilograms? So 80 kilograms, the amount of aluminium present as a fraction is 54 over 94ths. Yeah, 54 94ths of 80. We work that out. So I'll do that calculator quickly. 54 divided by 94 times it up by 80 comes to 3 sig figures, comes to 46.0 kilograms rounded up. There we go. Alright, so that's how you do those types of calculations. They're not impossible. You just find the fraction of the element present compared in the whole of the RFM, and we work through it and take the fraction of the original amount, in this case 80 kilograms. You could have done it as a percentage, 54 over 94 times 100, give it as a percentage, and then find the percentage of 80 kilograms. I just kind of simplified it a bit, got there a bit quicker. Yeah, so check those ones out. They are quite common. But let's talk about this, I think, called the mole now. The mole is the key thing that we're going to talk about, and in the future tutorials it all links into this concept, right? So where do we start? What do we do? Lots of people find it difficult, complex. a lot of people just think it's a hairy thing that lives in the ground, which it is, but us chemists use it. And the way I look at it, it's another way of working in mass. I use it instead of grams, and I convert grams to moles and moles to grams. It's just a measurement for me. It tells me something that I need to go and weigh out and use in my reactions. That's all it is. So the official definition for a mole, well, one atom, as we talked of any element, is what was really kind of too small to weigh. We're working in such small numbers that it doesn't really work for us. So a chap called Avogadro thought, you know what, every atom within the periodic table, as we know, has a relative atomic mass. Each atom has a slightly different mass, because we talked about carbon, and we talked about carbon being that size, and sodium being that size, and hydrogen being the smallest of them all. He said, you know what, can't weigh these individual atoms, but if we took a huge number of these atoms, we could physically weigh them on the scales, on a mass balance. And so the number of atoms that he assigned to represent 1 mole, so 1 mole of any substance contains 6 times 10 to the 23 particles. All right. Now, if your standard form's anything any good, you realise that's an absolutely massive number. That's 6 with 23 zeros. I can't be bothered to write it all out. As you know, I'm a bit lazy, so I can't do it all. But that's what it means. It just means this huge number of atoms. Now, okay, it's a definition. It's there, but let's actually use it. Let's see what it comes up with. So I'm more interested in finding out if I want to weigh 1 mole of carbon atoms, what does that really mean? So he's basically said 1 mole of carbon atoms is 6 times 10 to 23 atoms, weighs 12 grams. Now, you may remember, let's go back to our periodic table, look at carbon, can't see it here very well, but carbon, yeah, relative atomic mass of 12. So 1 mole of these atoms, these huge number of atoms, yeah, is 12 grams. So let's see if that rule applies some with 1 mole. If I asked you to go and weigh me 1 mole of sodium atoms, what is that going to be? So let's go back to the table. It's going to tell you it's going to be 23 grams. Now, how do we know that? Well, look at the relative atomic mass of sodium. It's 23. So that is our clue. So basically 1 mole of element, of the atoms of the element, is equivalent to its RAM in grams. It's incredibly important to remember that. So if I wanted to, and I said to you, go and weigh me out, get me 1 mole of carbon atoms, you'd get your, can you see that? Oh, it's all gone. It's gone off. Turn it back on. See if it works. These never work. These things. Right. Okay. So here we go. I'm going to put this on here. I'm going to zero it up. Tear it. Yeah. That's good. That's good. So if I'm going to now, that's 0 grams. If I want to weigh out 1 mole of carbon atoms, you're going to know that I have to go and literally weigh. Oh, nothing's happening on my balance now. It's not being very helpful. Zero that again. I'll turn it off. I'll turn it back on. It never works else, does it? Come on. Here we are. Is that? No, 0. Right, it's all gone a bit wrong, but so I imagine I'm weighing out. I weigh out. I've probably put some stuff in there. It's still not working. Rubbish things. However, as in all blessed Blue Peter stuff, I have got some stuff weighed out already for you. So let me move that out of the way and go and grab you. Here's my carbon that I did earlier. So that's 1 mole of carbon atoms. That's 12 grams weighed out. So that's 1 mole of carbon atoms. I've got 1 mole of copper here. 1 mole of copper is 63.5 grams, and if we go and check it out on the periodic table and find copper, Cu, and you will see that it's 63.5 grams. So that is my 1 mole of copper. Perfect, Amondo. If I then go and let's just take one more, just out of argument's sake, here we go, we've got some magnesium here now. If you check magnesium out, magnesium is 24 grams. Pardon me, sneezing, hay fever, apologies. And that's 24 grams of magnesium there as well. So that's 1 mole. So you can weigh them out easy as you go. So all happy with that. So let's go back to our idea then. So if I said to you, I'll get something focusing in better. Here we are. So if I said to you, go and find me 3 moles of carbon atoms. I'm hoping that you would say that, well, 1 mole is 12 grams, so 3 moles is going to be 3 times 12 equals 36 grams. So you're going to weigh me 36 grams. Now, here's a formula that comes out from this now, and it's something that is really useful that we can use when we don't have such nice numbers and we can find out mass. Remember what you did. So you wanted to find the moles, MO, we abbreviated moles to MOL, yeah? Like I said, we are particularly lazy in chemistry. I don't know why we just can't put MOLE, but we keep it as mole. And what did you do? You took, sorry, start again. You wanted to find the mass, didn't you? We said the mass, and we wanted the mass in grams, okay? So we wanted to find it, it was 36. And what did we do? We took the number of moles, which was the mole, 3 of those, yes? And we times it by the 12. Now the 12 was the relative atomic mass, which was 12. So we do the RAM. So that would work out for us to be the formula mass equals mole times RAM. Okay, let's try another one. Say I had 64 grams of sulfur atoms, yeah? Right, so how many moles of sulfur do I have? Well, the first thing you've got to find out is what the relative atomic mass is. We want to find out what the mass of 1 mole of sulfur is, don't we? So if we find sulfur on our periodic table, S, it's 32. So we know that 1 mole is 32. So 1 mole equals 32 grams, yes? So if I have 64, the number of moles equals 64 divided by 32. I'm sure you can see that. And that comes out to be 2 moles, yeah? So what did I do to find the moles? I simply went mole equals the mass, and we always work in grams. I know in physics they like kilograms, but in chemistry we always work in grams. You took your mass, your 64 grams, and you divided it by your relative atomic mass, your RAM. Right, so basically we have that equation, so these 2 equations, and they can be rearranged or organized as you see fit. So I know some of you guys like doing a triangle, okay, and so what we can do is put the number of moles at the bottom, yeah? We put the mass at the top, that's going to be in grams, and on the other side we're going to put RAM. Now if you remember, we just looked at it, if you wanted to find the moles, we worked out the formula to be mole equals the mass over the RAM, yes? And we worked out the one before, because we knew what the relative atomic mass, 1 mole of any substance is the relative atomic mass of that in grams. So we're going to put the mass, put a finger over the mass, like I've done there. Mass equals mole times RAM. If you're good at rearranging equations, which I'm sure lots of you are, you could just learn that. Remember that one and rearrange it. You know, the RAM has come on the other side, becomes a times, so it's moles times RAM, gives you the mass. Now, RAM, relative atomic mass, does have a unit, and we could actually find the formula to find the relative atomic mass. Put my finger over put my thumb over RM so you can see it. It's going to be mass over mole, isn't it? Yeah. So the RAM equals mass over mole. Now you might remember we always work in grams for the mass. We said G stroke mole, gram per mole. That is the unit for the relative atomic mass. If you are really flash and you're pretty good at maths, it can be represented as G mol mole to the -1. The minus refers to the divide, and it's just to the power 1. So it's G mole to the -1. Okay, now that is the easiest way to use it. So if you're asked to work out the moles of substance, you find the mass, you divide by the REM. If you want to find the mass of a substance, you know it's moles, and you times it by the REM. Just need to practice using it, but you can see how useful it is. Moles is just another way of working out the mass of something, yeah? And those relative atomic masses are incredibly important to us, because 1 mole of any substance is the mass of in grams based on the RAM. This equation also works not just for relative atomic mass, it also works for relative formula mass. So you simply substitute into our triangle. The mole is the same, the mass is the same in grams, and this time we substitute the RFM in there. So you know the RFMs, so 1 mole of CO2, yeah, equals, well, we know the relative formula mass is 44 from the previous tutorial. So 1 mole, 1 times, so mass is going to be mole times RFM. So 1 mole times 44 equals 44 grams. So if it was 2 moles, it would be 2 times 44, and it would be 88 grams. So that is how we go about working it out, and we're going to, now you're going to have to remember these equations here, because we're going to start using them in the next tutorials. They're going to become second nature. So not only do you need to know how to work out RFM, we need to now apply it in equations. Right, we're going to now bring it into using balanced equations. Right, so good. We'll talk soon on the next tutorial. Thank you.